Okay, so we have the other time alpha what? Cube plus what? Beta cube. So we said this can be written as what? Alpha plus beta, then the bracket alpha square minus alpha beta plus beta square. Is that not it? So I said if you should expand this guy straight up, you are going to do what? Arrive back to this when you expand it. Should we try it? I've done before. Now, this is it complete? No, this is already complete. This is not yet complete. So let's complete. What do I have? Alpha plus beta, then alpha square plus beta square minus alpha beta. Recall that what? Alpha square plus beta square is what? Alpha plus beta all square minus. So when we put this guy inside this, what do we have? Alpha plus beta all square minus this alone. This is it. Then it has what? Minus alpha beta. So minus 2 alpha beta minus alpha beta is what? So x is equals to alpha plus beta, closing the bracket, we have alpha plus beta all square minus 3 alpha beta. So that's how you get it. That's how they get it. So look at it. So the goal is not to get a perfect expansion. Find to form your own expansion. Do you know that with the help of this, it can even help me to know minus alpha beta, because I will just substitute as what? Plus. Then leave it as what? Minus. That's all. Yeah, it will work. So let's try symmetry 8. So we're having alpha cube minus what? Beta cube. So like I said, we have it as alpha minus beta, then everything alpha square plus alpha beta plus beta square. I think what should have minus? No, Nabi? So let's see whether when we expand it, it's going back to this. Alpha beta, then minus beta, alpha square. So when we open the what we have, no, minus
alpha beta square minus beta cube.
So this cancel what? This cancel what? This. So we end up having what? Alpha cube minus beta cube, which is this. So that's it. So now, when you've already proven that when I apply this my expansion, I'm going to arrive back at the same symmetry function. So therefore, I can go with this. Can I clean this off? Let's continue. So hence, if that should be the case, we have alpha cube minus beta cube to be equals to what? Alpha minus beta, then alpha square. This can come with this plus beta square plus alpha beta. Now there's an issue. Recall this itself, it has a square root stuff. Recall that alpha minus beta was what? All the square root.
Alpha plus beta all squared minus all alpha beta.
Then this one also, alpha square beta square is known as what? Alpha plus beta minus 2 alpha. So that means this place I have alpha minus beta, it was in symmetry 4 or 5. Then this one I have alpha square plus beta square. That's symmetry 3. Now apply it. So what will I have? Alpha. Okay, square. Thank you. So what will I have? And the first one, alpha cube minus what? Is now equals to what? Alpha plus beta all square minus 4 alpha beta. Then this side, alpha square plus, alpha plus beta all square minus 2 alpha beta. Remember this outside as alpha beta plus alpha beta. So what would I have here? That's what? Minus, isn't it? All the square root of okay. I know some of us do you understand this thing? Let me go again. I said the first thing is to find a way. When you expand this thing, to go back to this case, isn't it? So when I expanded it, I arrived back to this. When I expanded this thing, when I expanded it, it came back to this. So we've solved that solution. Now you have to express everything here to look like alpha plus beta, then what? Alpha dot beta. Is that clear? So what do I do first? From here, this alpha minus beta, remember it's symmetry 4, no, or 5, either of the two. I actually gave you that anytime you see alpha minus beta, you put what? All the square root. Alpha plus beta square minus 4 alpha beta. That was in symmetry 4 or 5. Why this one was in symmetry 3? Which says that any place I have this alpha square plus beta square can be expressed as alpha plus beta in bracket all squared minus 2 alpha beta. Then so this here, substitute with this, we have this. Why this here? Only this, we have this, which is here. And don't forget that's plus alpha beta. So when I put plus alpha beta, here is like saying minus 2 plus 1. That's minus 1. So that's your answer. As far you end up having alpha plus beta, alpha beta, alpha plus beta, alpha beta. You can see, and I won't lie to you, it will be out. Just learn how to prove it. Ensure you know how to get to this side. Exactly. So let's try the one that involves symmetry 9. Symmetry 9 says when you have alpha in the power of 4 plus beta in the power of what? 4. Hello? Please, attention, please. Can I express this as alpha square, then square?
Yes.
Then can I express the beta square, then what? Square. Recall, remember I told you, know what we do to make it more easy for us. Assume that any place I have alpha square, let it be what? A. And any place I have what? Beta square, let it be what? B. So if that should be the case, here is alpha square. What will I put there? A square plus B square, isn't it? And remember this thing I taught you guys from here. So what will I have? A plus B all square minus 2AB. Now return it back. When I return it back, what do I have? My A was what? Alpha square, isn't it? Plus beta. You can see that. Minus 2. This guy itself is what? This guy can be written as what? Alpha plus beta all squared minus 2 alpha beta in bracket all squared minus 2 alpha beta all squared. That's it. Symmetry 10. Yeah. Please just learn how to prove them. Like I said, I can't cram all this in my head. It's a waste of time. Since I know what to do, simple. So the last one, alpha in the power of 4 minus what? Beta in the power of what? 4. The same approach. Please, if you don't understand anything, you can ask me a question. Okay, please. This one, Abby. Wait, let me start again. Let me ask. So far, so good. Everyone, do you understand what is going on in this class? Yes. Let's go. So my guy is asking a question. Now look at this. I said alpha in the power of 4 plus beta in the power of 4. This, please, the guy beside you. Kendi. Yeah. This alpha in the power of 4 can be written as what? Alpha square. in indices, it's called power law. 2 times 2, return back to this. 2 times 2, return back to this. So this alpha square, beta square, we now said assume it is A and B. So when you say A and B, that means any place that have alpha square, I put what? A. That way you are seeing it as A square. The square is this, the alpha square is A. That's that. Then, this case, I have beta square equals to B. That means any place I have beta square, I put B. The square is this, and the beta square is B. Then you use your normal expansion. That one I told you, symmetry theory. That we have A plus B all square minus 2AB. We now return back this A. Notice A was what? Alpha square. We put it there. This B was what? Beta square. We put it there. Then the square on it, this is it. Likewise, this A, alpha square. This B, beta square. This again is returning back to that symmetry theory. You do it again. The second time. When you try the second time, you have this, which is what is there. Then your square is on it. Minus 2 alpha. If you look at this carefully, they are sharing square, square. So being the square in one place, then you have it there, then you have your 2 outside. When you end up having this alpha beta, alpha beta, alpha beta, or alpha plus beta, you are done. You get it? I would have loved to stop here because these guys still have what? Alpha square, beta square. So I need to express it. That's the goal. So that's what we're going to do for you. Yeah. Don't please, that's a very good question. In your exam, that is why it is advisable. Hello, listen. Examiner don't instruct. They don't instruct people how the exam is going to be. You're not in secondary school. They tell you, when you want to write JAMB, they taught how you can use the computer system. I mean, some of us, they taught you guys. But in university, nobody's telling you anything. Please, when you're going to the exam hall, there are 2 things you carry on. A plain sheet, they will not see it from you. They will not give you plain sheet in the exam hall. Don't think it's JAMB that they will give you plain sheet. They won't give you raw sheet. Listen. They won't give you raw sheet. It's 2 ways. Tell the man, show the man his A4 paper. Like 2, take it in. In case the man didn't give you, say you're not supposed to come with any paper. Every of your exam script has a blank page. That means, exam question at the back of it, blank. Use that side. Are you seeing that? And you are expected to carry, I think they'll give you a place where you're going to write your stuff. So when you are doing all these things, your lecturer don't need all these things that we are proving here. The proof is meant for you to understand. So that you will not cram those words. So when you have that, when you want to do something like this now, you have to have a rough sheet. Because that book is not enough for you to do everything. So don't write everything, every step on the book. Find another book you can write those steps. So transfer it to, you get it. And get a better calculator. It's not everything you'll be solving. Fraction. All this fraction, throw it away. Don't be saying 1 plus. This can be written as what? Alpha square, abi? All square. Then what? The same thing, assume. Let's use x. Alpha square is x. Beta square. So if that should be the case, that's x square minus what? Same thing, s plus y, abi? All square then. Is it all squared or in bracket? Am I right? So returning back, what do I have? What's my x square? Alpha square plus what? Then what do I have here? Can you see what's going on now? So this one can be written as what? Alpha plus beta all square minus 2 alpha beta. We are done with this. But this one, remember, is not square root. Alpha minus beta, abi? Then alpha plus beta. This alone. Then remember this alpha minus beta is the square root. So we now write as alpha, we write it everything, we write them again. 2 alpha beta. Then square root, abi? Or square root alpha plus beta square minus 4 alpha beta, then alpha plus beta. That's all. How do you want to put this in your head in exam day? You can't put this in your head. So that we are done with quadratic and symmetry. I've taught everything now. So all you need to, you can solve question. No, the major one they will give is 10. I've not seen alpha power of 6, but in case they ask, you just assume. alpha in the power of 6, then, so we just assume here is 2, 3, abi? 2, then what? 3. Are you seeing that? So assume that what? Alpha square is what? A, beta square is B. So any place I see alpha square, I'll put what? A in the power of 3, then B in the power of 3. Recall, this thing I told you is what? A minus B, then A square, then A plus B, then B square. You can see that. So if you expect this very fast. A minus what? B. A plus B all squared minus 2AB plus AB. So what will I have? A minus B, A plus B minus AB, abi? So we now return back this what? A as what? Alpha square, B as what? Beta square. Expand again until you have a long answer. That's how you solve it.